can you quickly take a derivative of something like this? And what would that be?
Wait, what question? Oh,
Derivative of this, yeah, you're seeing my screen there.
so it would be just one. Um, second, and then what would it be?
Sometimes help to rewrite it
So
slightly.
it'd be -4/x².
Yeah, and that's the preferred way to write it. Um, so now you have to set this equal to 0. So could you quickly solve for, the 1 or 2 critical points here for that?
Would it be x=2, x=-2?
Very good. Okay. So now the next thing you can do here is on a number line, you can put those critical points here, and this is the derivative, and you have to test in the derivative now. So I always recommend testing, uh, putting those test points here, um, and here. Now you only care about the sign. You don't care about whether what the actual value is. Now, one of the things that we did not do here is restrict the domain. There's not a critical point, but it's a place where it's um it's where it's undefined.
Yeah.
So do you agree? Do you see that it's undefined there at 0?
Yeah.
Okay, so 0 can't be a test point. Like seems like a good point, but you also have to consider those things as well. So you want to test now a point on either side of it. So we'll go like 1 and -1.
Uh-huh. Should I plug it in?
So you have to plug these values into the derivative. And you only
Okay.
care whether it's positive or negative. That's the other thing. Like again, like you don't get so caught up in like, well, what is it actually? Just, relative size of numbers.
Um, would -3 be positive?
It is not. Um, because you're
Wait,
squaring it, so it's 1 minus 4/9,
yeah. One
smaller than
minus
1,
4/9 would be 5/9, right?
right? So that's positive.
And then -1 would be negative, right?
It is negative. Yep.
And then 1 would also be negative, and 3 would be positive.
Right. So now you can figure out whether they're mins or maxes. So the idea is that if it goes from plus to minus, that's a max. Minus to plus, that's a min. Okay. And so um, the other possibilities is if it goes from like minus to minus or plus to plus,
Mm-hmm.
that's nothing. So this right here at -2, this plus to minus is a max, and this minus to plus is a min.
Mm-hmm.
That
So
makes sense.
-2 is
-2 is a max and 2 is a min.
Okay.
All right, now this is the first derivative test. They actually wanted you to use the second derivative test. So we're going to look at that now, but you need to know both, so we might as well cover both. So the second derivative test means you got to take a second derivative. What is the second derivative of this?
Wait, do we have to do that for number two?
Well, you need to know all of it. So, we might as well cover both tests. But yeah, let's do the second derivative of this, and I'll talk you through how to figure that out.
Um, -2. Would just be positive 4 over x thirds.
So if you rewrite this as 1 minus 4x to the minus 2, and then you take it over, that might be easier. 8
Oh,
over x cubed. So now the reason this is so nice is if you test your critical points, okay, if you test your critical points, so you do like f double prime of your critical point 2, which ends up being 1. Since this is greater than 0, you know that it's a min. That's what the second derivative test says. F double prime of -2 ends up being -1. Since it's less than 0, that's a max. So if the second derivative is greater than 0, it's a min. If the second derivative critical point is less than 0, it's a max, like that. So that is the second derivative test. This right here is the second derivative test, but you also can use the first derivative test.
okay.
All right. Are there any others in that 1, 3, 4 that you would like us to kind of talk about? I mean, maybe we should do a trig one, maybe not.
Maybe we could do one trig one.
Okay. So let's do 4, I guess. Oh, they're all bad. So it says do not use your calculator. On problems for component. Okay. All right. So you got to be able to take a derivative. What is your derivative of this?
Um, so it'd just be 2 cosine x.
Okay.
Wait, sorry. And then minus 2 sine x, minus 2 sine 2x.
Works. All right. I'm going to drop in the chat here the I'm going to drop in chat that reference sheet for trig, and then also the one for derivatives and integrals. If I can find it. There it is. These will really help you, in general. So you got to set this equal to 0. One of the big problems here is that sine of 2x doesn't really match with cosine x, but sine of 2x is a double angle formula. It becomes 2 sine x cosine x, which means that this becomes 2 cosine x minus 2 times 2 sine x cosine x equals 0. You have 2 cosine x minus 4 sine x cosine x, like that.
Wait, sorry.
Sine 2x is a double angle formula. That's why I sent you the trig cheat sheet. You got to know all your trig
Wait, so
formulas from calculus 2.
the derivative of 2 sine 2x is 4 sine.
No,
uh,
no, no. We're just rewriting sine 2x. Sine 2x.
Oh,
This is your derivative, but you have to rewrite it here. Otherwise, you can never solve this equation.
can we use a calculator?
No. I mean, you can, like the instructions say not to, but I mean, you can do whatever you want, truthfully. So, like I said, that's why I kind of prefaced like everything I said, because like I'm helping another calculus 2 student, and it's just a challenge. It's just a challenge. This is really a serious math class with you know. All right. So now you can factor out a 2 cosine x from both. You can set that equal to 0. So you can set both of these equal to 0. 2 cosine x equals 0. 1 minus 2 sine x equal to 0. And then you can solve these. So take a look at that unit circle. Where is cosine x equal to 0? Where is sine x equal to 1? What are those? What are those values?
Wait, sorry. Writing it down. So it would be pi sixth.
For which one?
Oh boy. Pi sixth and 5 pi sixth. Yeah.
Okay. How about where cosine is equal to 0?
Pi halves and 3 pi halves.
There you go. All right. Now, if you're going to use the second derivative test, you actually want to come back here to this line and you want to take another derivative. So let's have you do that. Let's take your second derivative from here.
Um, Wait, but why do we need to take the second derivative?
The instructions say to use the second derivative test, which for this problem is definitely probably preferred.
So it'd be negative 2 sine x
Yes.
and negative 4 cosine 2x. I mean, positive 4.
Derivative sign
But
is
negative.
cosine positive, so yeah, and lots of places to make mistakes there. So now let's try the easy ones. The easy ones are the ones that are on the, up, down, left, right on the unit circle. Can you evaluate the second derivative of pi over 2? What's sine pi over 2, which is the cosine of pi?
Um, it'd be negative 2 minus 4.
So cosine of pi is -1, so it'd be +4, which equals 2. Since that's greater than 0, this is a min.
Okay.
And so it's easy, you can see it's just so easy to make some of those mistakes. Let's try 3 pi over 2. So -2 sine 3 pi over 2 minus 4 cosine 2 times 3 pi over 2.
It'd be the exact same.
It is not the same. I mean, you should be very careful with your signs.
It'd be 2 plus 4.
Yes. Which is 6, which is greater than 0, means it's a min. Now we're gonna do the hard ones. Ugh. It's like, what do we do? So you can see, like, you got to really be strong with your trig. F double prime pi over 6 equals -2 sine pi over 6 minus 4 cosine. 2 times pi over 6 is pi over 3. So, if you need to have that unit circle out.
Um, so getting the unit circle. So sine of pi sixth would be, so it'd be negative 2 times 1/2, so negative 1. And then pi thirds would be 1/2, so negative 4 times 1/2. So negative 2.
It's less than 0, so it's a max. Again, you don't have to actually get the value. Like once you figure out, once you realize they're both negative, you can say, oh, it's less than 0, that's a max. Some teachers want you to get the full one. So now 5 pi over 6 minus 2 sine 5 pi over 6. It's similar. It's not exactly the same. 2
Would it
times
be
5.
1 minus 2?
You gotta be careful here. Yeah, 2 cosine in the second quadrant is negative though. Um, so that ends up being positive.
Mm.
But that one in the second quadrant, sine is still positive. That one's actually -1 plus 2, which is 1, which is greater than 0, which means it's a min. And another reason these problems take so long is they're just pages and pages of stuff that you're doing. Okay. I don't know. Does 5 or 6? They're very different, but do either of them look of interest to you?
Wait 1 second. Wait, for 5 pi over 6, it'd be cosine of 10 pi over 6 is cosine of 5 pi thirds, which is 1/2.
Oh, that's right. So it would be -2. Get you -3, which is less than 0, so it's a max. All right. Is that okay?
Yeah.
All right. So 5A is a tangent line. Um, X
Wait,
6
so are
is
we
a
doing
plus.
5?
That's up to you. We can talk about.
Sure.
Okay, so we'll look at 5A. This one's a little deceptive because there's so much going on. You might think that it's more complicated than it actually is. It wants the tangent line of F. What is the point slope form of a line?
Um, what does that mean?
So this is y minus y1 equals mx minus x1. Now from your previous course, how do you find m when you're in calculus? What does m
The,
represent?
the slope?
Slope. Do you have the slope when x equals 1 of f?
Um, yes.
What is it?
-3.
Yes. So actually has nothing to do with this mess down here. Now, do you know an x1 and a y1? Do you have an ordered pair? Do you know the y value when x is -1?
Yeah, 2.
So do you have enough for this? Yeah, you've got an x1 and a y1, and you've got a slope. So it's y minus 2 equals -3x plus 1. That's everything for part A. So really, not even there's not really any calculus there. But let's continue here. All right, part B. Part B. Does
Wait, can you go
G,
up a little bit?
sure,
Okay. Okay, yeah. I just have to write that all down.
does G have a local max or local min at -1? So you have the derivative here. you don't have any way of setting this equal to 0. Well, actually, I take that back. You could, but I would recommend not doing that because I think we're gonna miss some information. So I think they're really sort of saying, hey, you've got to take another derivative of G. You got to take the derivative of G prime, basically. All right. So, and this is a little uncomfortable for most students, but what is the overarching derivative rule for something like this? If you're going to take the derivative of something like this.
Like chain rule.
I think it's product rule.
I mean, yeah, product rule, sorry.
Like an, I guess I like U and V, but okay. So when you take a derivative, do you like to keep the first or take the derivative of the first?
Um, doesn't it not matter?
Yeah, it doesn't matter to me. I'm asking you what you want because it really doesn't
We
matter to
could do
me.
the we could do the first.
Keep the first or derivative of the first.
We can derivative of the first.
All right, so give me the derivative of u. What's the derivative of x to the fourth minus 6x cubed?
Um, 4x cubed minus minus 18x squared.
Okay, keep the second, so 3 f of x plus 2 f prime of x, okay, plus, now we're going to keep the first. The derivative of f of x is f prime of x. The derivative of f prime of x is f double prime of x. So even though it may look odd, you just say, well, its derivative is the derivative. All right, now we want to evaluate it at -1. We need to do g double prime of -1. Okay. And so the only sort of challenging spots might be, well, do you know f of -1? Yes. F of -1 is given as 2. F prime of -1 is -3. And f double prime, well, that's -3 there. F double prime is given, if I could find it, 5. So you just got to calculate all this with x is -1, substitute these in. Is that okay? Clear?
Yeah.
So we got -4 minus 18, and then that's 6 minus 6. So notice that goes to 0. That's nice. Plus 1 plus 6, -9 plus 10. So this becomes 7 times 1, which is 7. It's greater than 0. That means it's a max.
Okay.
When it's a justifier answer, you can just maybe say second derivative test, although it's kind of obvious if you took the second derivative and you evaluated it. Meaning like somebody grading it would know that. They would say, yep, use the second derivative test. So 6 is an implicit derivative. Part A is just like doing the derivative. Um, part B relies on the derivative. Part C is doing yet another derivative of that. Do you want us to look at any of that or move on to
We can
8,
move on.
7? Sorry.
We can move on.
Okay. All right. On problem 78, the graph of the derivative is shown. Okay. This is super, super important here. I'll do it for 8, and then maybe I'll have you do 7. So the rules for the derivative are just, they're just different. Um, so this is if you're looking at the derivative, and then this is f prime, like they're telling you that's the derivative. So when the derivative is greater than zero or above the x-axis, that is when it's increasing. So you say, okay, there. All right, so when it's above the x-axis, so from -1 to 3, and from 5 to 6, it's not clear whether the graph is going on forever. You might ask your instructor, is that mean it's going on forever? It doesn't look like it, but maybe it is. So it could be infinity. Not really sure. But it's different. It's increasing. The original function is increasing. Uh, sorry. The original function is increasing when the derivative is above the x-axis. So similarly, when the derivative is below the x-axis,
Mm-hmm.
it's decreasing. The original function, so f is decreasing. So it's decreasing from -infinity to -1, comma. Uh, so there's another thing here. No, well, we don't need to address that here. From 3 to 5, it is also decreasing. So the other thing you can do here is draw a number line where you have those numbers, -1, 3, and 5, and you can say, okay, positive above, negative below, positive. And to determine where it has a min or a max, you're just looking at, well, where does it go from plus to minus, minus to plus? So again, minus to plus is a min, plus to minus is a max, minus to plus is a min. Min means it's coming down, max means it's coming up, min means it's coming down. And it has nothing to do with the graph. Like the graph is deceptive. It's the original function we're talking about. Do you have any questions or thoughts on that?
Mm, no,
No? Okay. All right. So I'd like you to try 7. So again, they're giving you the graph of the derivative. So we want to know where f is increasing, where f is decreasing. It's the same rules. It's the same rules as before. It's where the derivative is less than 0 or greater than 0.
so 0 and 3.
What is 0 and 3? Is it increasing or decreasing?
Um, it increases.
Let's
What's
go
it?
back and look at the rules. It's increasing when the derivative is above the x-axis. It's
Okay,
decreasing when the derivative is below the x-axis.
so it's increasing from negative infinity to 0.
Okay, I agree. And then what else? What is the other interval?
3 to infinity.
Okay. All right, what else? Now decreasing. What do you say about decreasing?
Um, sorry, 1 second. From 0 to 3.
Very good. All right, now if we draw this number line of the derivative at 0, at 3, so we have increasing, decreasing, increasing. Is 0 a min or a max?
Second. Um, so from positive zero's a max.
Read. And at 3.
It's a min.
Very good. All right. Good job on that. Okay, so where it gets tougher is um, there's even more rules for the second derivative. Oh man. So what they're graphing here is the second derivative. Okay. And so the rules are different, but an inflection point, inflection point is when the second derivative switches plus to minus or minus to plus. So when you're looking at the graph, what that means is it um goes I won't get the right word here, like um sw sorry, give me just a second here. It's crosses the x-axis. It has to cross. That's the right word. So where does it cross the x-axis?
Um,
Where does
at
this graph cross the
one,
x? Yeah, 1 and
7.
yeah. Those are both inflection points. X equals 1, x equals 7. What you could do is you could draw a second derivative sign chart here where it equals 0, which is at 1, 4, and 7, plus, plus, minus, minus. And you can see that it switches from minus to plus or plus to minus at those 2 points. So what's challenging for most students is to remember the rules because they're different whether you're looking at the original function or the derivative or the second derivative.
Okay.
All right. I think that's it. Yeah. Okay. We got, 10, 12 minutes left here. Um, where do you want us to go? 10 is like kind of um related. I mean,
Maybe 12.
okay. So 12, one of the things about 12 is that there's actually there's a lot of graphs that work. So you generally don't get this. It's hard for people to grade. Is the truth. Like there's a lot of right answers. So what really you need to know is like what each of these things mean. Um, if the domain of F is from minus infinity to 0, union 0 to infinity, that means something's going on at 0. Okay. And we don't know what that is. It could be a hole, a jump, or an asymptote, but something's going on there. Something's going on there. We don't know what. Okay. B here says f of negative x equals negative f of x. Do you remember anything about what that means?
About what means?
This means this is something, part B is something has a, like there's a known meaning to that.
Like the inverse?
It is not inverse.
I'm not
So
sure.
sine has this property. The graph of sine has this property.
Oh,
But that's not, I'm just trying to give you an example, something that might help to.
Okay. So what's after?
So this is an odd function.
Okay.
Odd function. So it's got like rotation symmetry, which
Okay.
basically means like whatever it looks like top right, it's going to look like on the bottom. It's gonna be rotated about the origin. So um, that's just this small thing. How about this one here? Limit as x approaches zero from the right, f of x equals infinity. What does that mean?
Um, like it goes positive. It's going up.
Okay, so that's a vertical asymptote. We know there's probably a vertical asymptote there at there. What about the limit as x approaches infinity, f of x equals zero?
That it's going towards the asymptote.
Nope. That means infinity means you're going to the right forever. That's a horizontal asymptote.
Okay.
So this is the vertical asymptote. This is the horizontal asymptote. All right, now it says f of x equals zero only at x equals one. So that's a point. It says so that's a point. That's the important thing here. F prime of x equals zero only at x equals two. What does it mean when the derivative is zero?
Yeah, it's like horizontal.
It's got a horizontal tangent. We don't know whether it's a min or a max or neither, but it's got something going on there. And then f double prime of x equals zero only at x equals three. That's a possible inflection point.
Okay.
Okay. So we got to work that out for us. So it's like, well, what does this even look like? Well, the whole point of this like odd function thing is like whatever you do in the top right, it's going to look like that's in the bottom left. So at two, I mean, there's a lot of things you can do at two. Two can be a min. A min makes the most sense at two. Like you could come down, cross, there's a min. Okay. And then at three could be an inflection point. So at three, it switches from being concave up here to being concave down, and it goes that direction. It still approaches zero. So this right here is right there, and then this green is kind of right there. That's kind of the inflection point, kind of. But there's other possibilities, but this is more or less what they're looking for. But then we have to basically draw the same thing on the other side, which means we've got to have basically the same look, but from the other side. So thumbs up, something like that would do it.
Okay.
This is a pretty challenging one. Like this isn't like the starter one. So I would certainly understand if, this didn't make a lot of sense. But hopefully when you see this next time, you'll remember some of these things about all the different features of the graph.
Okay.
Okay, what else would you like us to look at?
Wait 1 second. I'm just still copying it down. We could just finish up the worksheet, I guess.
I'm sorry, did you say a specific problem?
It doesn't matter which problem,
All right,
we could
let me
just
go to
get
10.
one.
That was kind of like there's some, throwing some easier stuff as well. So H of two has nothing to do with calculus. H of two is composition, F of G of two, something you see in algebra two. You first find G of two. Can you look at the graphs and tell me what G of two is?
Um, G of two is one.
It is one. Okay. And then F of one, what does that become?
Um, F of one would be, wait,
The output becomes the input.
so like 3 point something.
Yeah, whatever. 3 point, whatever, three, two, something. All right. Good, 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 good. Now the part B, part B here is based on this function again. It wants you to find the derivative, which at first glance doesn't feel like you can do, but with composition, you can take your derivative here. So your derivative is derivative of the outside function, keep the inside function times the derivative of the inside function. That's a pure just chain rule derivative. So h prime of one, you start putting your ones in here, and then I'll grab the graphs again. Okay. So give me g of one, roughly.
Like 1.75.
I mean, I think it's trying real hard to get to two, we'll say. Let's just call it two. So that's f prime of two. So now when you go to two, what's the derivative at two?
0.
Looks like it's zero. Yeah. And then the derivative at one, it's some sort of a line like that, but it doesn't really matter because zero times anything is, let's call it, I don't know, negative, two. It's still zero.
Okay.
All right, so let's try one more here. We'll have to grab these graphs again. So is the graph part here, is it increasing or decreasing at three? So we got to go back to this notation here for the derivative. So at three, what's going on at three? So first, like, what's g of three? G of three is,
Um, Wait.
what's g of three? Start with the inside function.
G of 3 is 3.
Okay, so now f prime of three, and try to think of it in terms of positive or negative. Is the derivative positive or negative there?
Wait,
The
what?
tangent line. The tangent line at three. Is it positive or negative?
Negative.
Negative. So overall it's negative. How about g prime of three? What's the tangent line at three? Is it positive or negative?
Positive.
So a negative times a positive is,
Negative.
which is less than zero, which means it's decreasing. Decreasing.
Perfect.
All right. Well, I hope you guys get to the calculus BC stuff soon. This is definitely not it. We're gonna go ahead and stop here for tonight.